end up feeling really smart because it's not too bad. This is the unit circle in great detail. So it gives you what are called the key angles. Every multiple of pi on 3, sorry, pi on 6. So pi on 6, that's 2 pi on 6, and effectively that's 3 pi on 6, or half pi on 6. There's all the pi on 3s and pi on 6s around, and there's also the pi on 4s, so the quarters. And in stage 2, all the angles you'll deal with are these ones. They are these special angles, and you'll get very used to reading this. Probably worth reminding ourselves that this coordinate point here represents cos of pi on 6, and that one there represents sine of pi on 6. And tan is the sine divided by the cos, or the opposite over the adjacent. So really, this gives us a lot of information. So, the first question asks for the sine, cos, and tan of pi on 4. So you're looking below at 1a, and if we're looking at sine of pi on 4, what is that answer according to our circle? Yeah, root 2 and 2. Good. Cos of pi on 4. Exactly the same thing again. Tan of pi on 4. It's root 2 on 2 divided by root 2 on 2, but what's something divided by itself? 1. Yeah, 1. So our first answer is that. And that's it. Alright, we won't do all of these, we'll do a couple. Let's do B. So that's 3 pi on 4. Sine of 3 pi on 4. For that, we find where it is on the circle, and it's there, the y coordinates exactly the same. It's the same height as the one before, so root 2 on 2. Note that your calculator or somewhere in the textbook might do this to get an alternate answer. They might write that as root 2 over root 2 times root 2. Are you happy that that 2 is the same as root 2 times root 2? And therefore they cancel this out, and you might see it written as 1 over root 2. So it's probably worth making a note to yourself that this number here is actually the same as 1 over root 2. And they'll pop up interchangeably because they are the same number. One just has a rational denominator, the other has an irrational denominator. Either answer's fine, they're both equally correct. Cos of 3 pi on 4. Minus root 2 on 2. You need the sign, it's out here with the negative. And then, last one, tan of 3 pi on 4. Yeah, nice, minus 1. Because it's this divided by this. The same number, but one's negative, so minus 1. Alright. Now to save us writing, or me writing, would you be happy to read off 7 pi on 4? It's just this one here, isn't it? 7 pi on 4 is there.
Negative root 2.
Nice, that's the sine, and then root 2 over 2 is the cos, and then minus 1 will be the tan. What about pi? What's sine of pi?
0.
Nice, because it's 0 up. Cos of pi? Nice. And then tan of pi. Remember, tan is sine divided by cos. So it's 0 divided by negative 1. 0. Nice. So tan of pi is 0. Alright. Given that is not too bad, let's look at the last one, E. Minus 3 pi on 4. Now, there's no angle here that's written as minus 3 pi on 4. So where would you have to go to get minus 3 pi on 4?
3 pi on 4.
Well, 3 pi on 4 is positive 3 pi on 4, but you want to go the opposite way. So you're going 3 pi on 4 this way. That is the equivalent to minus 3 pi on 4. And therefore you're looking at these. So they won't always necessarily give you them as positives. you should be able to take a -1 and navigate back around the circle to land on.
Would the negatives in the sine and cos be positives then?
No, because you're still at this location on the circle. And those negatives are an indication of the location you're at. So you might have gone back at a negative angle, but you're still at this negative spot here.
Yeah.
Alright. Let's make ourselves look smart. If you show this, for example, to a year 7 student, they're going to immediately freak out. But it's actually not too bad. We'll start at A. Sine squared 60. Sine squared 60 is the sine of 60 squared. So the sine of 60, there's 60. The sine is how far up it is. The sine of 60 is root 3 on 2. So really, this is root 3 on 2 squared is 3/4. One take cos squared pi on 6. One take cos squared pi on 6. Right? Again, we're aiming for no calculator. So what's cos of pi on 6? Well, cos of pi on 6, that one.
3.
Yeah? And if we square it, are we happy it's 3 on 4? So this is 1 take 3 on 4. 1 take away 3/4 leaves us with 1/4. Alrighty. So next one. Sine of 3 pi on 4. What is it? Yeah. Root 2 on 2. Take. Then what is cos of 5 pi on 4? Good. Take 2, -1. Now the trap here is the negative. You have to leave the minus in, and then the cos of 5 pi on 4 throws a minus anyway. So you're happy that becomes a plus?
Yeah.
Cool. This is half of root 2, and this is another half of root 2. If you add them together, you just get root 2. The intermediate step is you could have gone root 2 on 2 plus root 2 on 2 equals 2 root 2 on 2 equals root 2. All right, last one. Tan squared pi on 3, take 2 sine squared pi on 4. All right, let's do this one first. It's going to be harder. We're going to work out what tan of pi on 3 is. Pi on 3 is here. Tan is the sine divided by the cos. So it is root 3 on 2 divided by 1/2. So this one here becomes root 3 on 2 divided by 1/2 squared. I'll tidy it out the next line. Take 2 and then sine of pi on 4. Sine of pi on 4, we've seen it before, it's root 2 on 2. This becomes root 2 on 2 squared. Alright. If we divide with a fraction, we can change this to multiply and flip it. Are you happy that when we flip, there'll be a 2 at the top, and it'll cancel a 2 at the bottom? And then there'll be a 1 at the bottom from that one, so it'll be really root 3 on that 1. which is just root 3 squared, 3. So it jumped a few steps there, but 3. Take, this square hits the top and the bottom. So it'll become 2 over 4. 2 over 4 is a half, yeah? 2 times a half is 1. So it's really 3 minus 1, and the answer is 2. So I find it moderately satisfying to see something that freakish come out to that, which is cool. All right, there is more stuff I want to teach you this lesson, but first I'd like to practice pulling information off the unit circle and finding values from it. So could you please have a shot at those? Don't do the ones we've already done. So we've already done part of question 5. Have a shot at those, and I'm feeling like 20-25 minutes, and we'll come back to round 2 afterwards. So what we've been looking at so far has been a process where we have cos of some sort of angle or some sort of trig identity of an angle equals, and then we're asked to find the value from the unit circle. In this case here, cos of a third, if we find on the unit circle, most people are pretty happy to say that's a half. What we're doing now is we're going the other way. Rather than having cos of some angle equals a half, I'm going to be asking what cos of some angle equals a half, what is that angle? And that question might be phrased as something like this. Find all the angles between 0 and pi on 2 with the cosine of a half. Now, when it says angles, you should be like ringing little alarm bells because there's more than one. This here is definitely a solution, because when cos is equal to pi on 3, we get a half. So one answer for theta is pi on 3. But if we're thinking unit circle, pi on 3 is about there, and that has a cosine value of a half. And you can see that from the unit circle that's on the sheet immediately under here. But where else has a value of a half? Yes, there. That. My computer's glitching. 5 pi on 3. And you can see that that is a half across, and your other solution is down here as well. So, for this question, asking us for cos theta equals a half, the solutions are theta equals pi on 3 and 5 pi on 3. So that is the two solutions within one rotation of the circle. And that is what this is telling us, is that in one rotation, so from 0 to 2 pi, we have a solution here and we have a solution here. And those are the two solutions. In theory, they can ask from 0 to 4 pi, meaning we have a solution, we have a solution, we have a solution, and we have a solution. And there are 4 solutions as we keep going round the circle. And that's where this is going eventually, but for now, we're just going to go around the circle once in most of our questions. So, let's do one in our calculator. These almost never happen, but it's worth to check our answers. So grab out your calculators. Alright, and go to graph mode. So menu 5, delete whatever's there, and then because the question says between 0 and 2 pi, we want to make sure we're in radians. And your calculators would jump between degrees and radians this year. So to check you're in radians, hit shift and then setup, and just scroll down until you come to angle, and it should say radians. Otherwise, none of this works. You go shift, this shift button here, where my arrow is, Then click menu, which is the setup, and toggle down until you hit.
How do you change it?
So here, you can then press either F1, F2, or 3, which will give you degrees, radians, gradients. So you want to hit F2. Alright, then hit X to come back to here. If we have an equation like, what is it? 2 sine x take cos x equals 4 take x. If we want to find where they meet, one way to do this is to have this as one equation and this as another equation, and then we're going to look at where they intersect. So, type the two equations in separately. So 2 times sine x minus cos x, and then in the other equation 4 take x. And then we want to do something sensible with the view window. The view window for x needs to be between 0 and 2 pi. So hit shift and then view window. And the x values, I would keep x at 0, and I would change the maximum x to 2 pi, which it kind of is right now. But if you do 2 times shift power of 10, you can enter in 2 pi and hit it exactly. And then you should draw a graph that looks something like that. And if you want to find the solutions to this, you hit gsolve intersect, and you get 1 solution, 2 solutions, 3 solutions. And at those 3 values of x, both sides of the equations are equal, and therefore they are solutions for x. Now most of this is non-calculator stuff, but if you do want to check your answers, you can always do this, basically. How it where it meets? Oh, good? Cool. Alright. Leaving that alone for now. Let's look at it with no calculator. Alrighty, so first equation, 2 cos x equals minus root 3. For all of these, you're going to want to try and get the trig portion on its own. So for here, to get the trig portion on its own, a good first step would be divide by 2. And divide by 2. This will then leave us as cos x equals minus root 3 on 2. When you have the trig portion on its own, it's time to hunt for the unit circle. So where on the unit circle is cos equal to minus root 3 on 2? Yes, 240. We'll answer in pi though, so yeah, certainly 4 pi on 3 and
5 pi on 6.
5 pi on 6. Is that really it? Minus root 3 on, no, that's the sine value.
Yeah, 5 pi over 6.
5 pi over 6 is good.
And then 7 pi over 6.
7 pi over 6. So our two solutions here are x equals 5 pi on 6 and 7 pi on 6. Yeah, so it's a matter of being careful you're grabbing off the cos or the sine depending on what it's asking. So in this case, the cos being the x coordinate. Alright. 2 more equations. 2x take 1 equals 0. Sorry, 2 sine x take 1 equals 0. Any guesses of good places to start here?
5 by 2 sin x 3.
Yeah, throw the 1 over and divide by 2. So you have to add 1 and then divide by 2. Add 1, divide by 2. I'm going to get sin x equals 1 over 2. Yeah, beautiful. Now, where does sin x equal 1 over 2? Lovely. X equals pi on 6 and 5 pi on 6. And you know that here sin x is positive, so you should be like searching towards the top half, and you'll get quite quick at finding those solutions. Last one. And this is where we get perhaps a little more tricky. Sine squared x equals a half. Yeah, good, square root. And as normal when we square root, we want to do plus or minus. So sine x is equal to plus or minus root 1 on 2, which is plus or minus 1 on root 2. But bear in mind that 1 on root 2 is the same as 2 on root 2 on 2. So they're interchangeable. So if you're asked to hunt for this, it could also be that one. On that note, for what values of x is sine either plus or minus root 2 on 2?
Oh, and then some.
5 pi on 4.
Pi on 4, definitely, because it's plus root 2 on 2 there. 3 pi on 4, because it's plus root 2 on 2 there. 5 pi on 4, because it's minus root 2 on 2. 7 pi on 4, because it's minus root 2 on 2. So it's possible to get 4 solutions with a plus or minus here, because you're looking at spots above and spots below. So our answers are pi on 4, 3 pi on 4, 5 pi on 4, and 7 pi on 4. Which is pretty neat. So as you go through these, you might have 1, 2, or even more solutions. 4. Alrighty. This isn't the only thing I'll do this double. We get more complex after. But for now, can you finish the last of that question 5 if you're still on it? And then go on to 5e. Is that good? And 5e is about solving the trig equations like this.
Are we doing 5e?
5f? 5f?
That's a gradient straight line.
5e.
You just finished 5e.
Oh!
We haven't done.
We've already done. Question
Sorry.
mark.
Yeah, 5e. Keep going. Sorry. Round 3 of this is as complex as it gets for stage 1. And before we dive into the first question, I'd like to just sort of highlight this. We've done these in a few equations now where x is between 0 and 2 pi. If I tell you x is between 0 and 2 pi, what are the possible range of values for 2x? So if x goes between 0 and 2 pi, what are the values that 2x contain? Yeah, good. 0 and 4 pi. Because at the low end, we know that if x is above 0, 2x must also be above 0. If x is below or equal to 2 pi, double that must be between 4 pi. So we have this idea that if x goes between 0 and 2 pi, 2x adjusts its range. Similarly, what if I was looking at x on 2? What is the minimum value of x on 2? Yeah?
Oh,
Yeah, good, we're halving it, so still 0.
And then
Yes, well done. So we will start restricting or changing the values. One more step. Or, no, let's leave it there actually. Now, and I'll draw your attention to this equation. Sine 2x equals 1 on root 2. Now, for this, there are a number of different techniques. But my preferred technique is to make a replacement. What we don't like seeing is something there other than just x. Because we know that sine x makes this easy, but sine of 2x or sine of something else odd in here makes it slightly strange. And so I would say that if sine of 2x is this, with x being between 0 and 2 pi, our first step would just be this. Let a, or some other letter, equal 2x, and therefore a will stretch in those values there. So if I let a equal 2x, if x goes between 0 and 2 pi, are we happy that a can go between 0 and 4 pi? So there's like, it goes for a longer distance. And therefore what our equation boils down to is sine a equals 1 on root 2 for a between 0 and 2 pi. Alright, now we grab our unit circle, which I think I stashed over here somewhere. And for what values of a do we get 1 on root 2? Remembering this.
Pi over 4.
Good, lovely. Pi over 4?
3 pi over 4.
Lovely. So pi over 4 and 3 pi over 4. That would be in the first rotation. But this here is indicating we're going another rotation. We're going up to 4 pi. So for these, we take our solutions and we add 2 pi to them. So if we have this as our first solution, when we go around again, it is 2 pi plus pi on 4. So we would have pi on 4 plus 2 pi. And we have 3 pi on 4 plus 2 pi. Now, these are going to take a little tidying, but I'll do that in the next line. A equals pi on 4, 3 pi on 4. For these, how do I make that so I can combine it together? We want a common denominator, so I would bear in mind that right now it's over 1.
4 pi on 8.
Times it by 4, so it becomes 4 pi on 8. And if I add them together, sorry, not 4 pi on 8. 8 pi on 4, I'm going crazy. If you times top and bottom by 4, 8 pi on 4. If I add them together, you're happy I get 9 pi on 4. Because there's like 8 pi's there and one of them there. So I get 9 pi on 4. And then here, I'm adding another 8 pi on 4. 8 pi on 4 plus 3 pi on 4 is 11 pi on 4. Alright. There are 4 solutions for A. 4 solutions coming from the 2 rotations. Bear in mind, the question didn't actually ask us to find A, we've just invented that. So we have to undo that substitution. A is 2x. So at this point here, I can do this over a whiteboard, yours might not look as pretty. I would just say, okay, A is actually 2x. And then I'm going to divide it by 2. And when I divide by 2, I hit every answer to get x on its own. So therefore, x equals pi on 8, because I divide it by 2. 3 pi on 8. 9 pi on 8. 11 pi on 8. And it throws out 4 solutions. So the process here is, pick a dummy variable to substitute, adjust the range of the dummy variable, then solve as normal, and right at the end, undo the replacement, and write out your full set of solutions. And this is checkable on the calculator. The calculator will spit out that set of solutions, but it's definitely doable by hand as well. So let's do 2 more. And I hope we have time. Alright. If cos x equals a half, sorry, cos x on 2 equals a half, what's a good solution? A good substitution, rather. Well, a equals on 2. And a will be greater than or equal to 0. And what's the high end of a? No, it's just pi. Because if x has a maximum value of 2 pi, then a will have a maximum value of just pi. And therefore we're solving when does cos of a equal a half. Alright, so we grab our unit circle. And when does cos of a equal a half?
Pi over 3.
Pi over 3. Where else is the other solution?
5 pi over 3?
Nice, but does this count?
No.
No, it doesn't count because we're only looking between 0 and pi. So between 0 and pi means we're between here and there. So that is the only solution here. So it makes our one quicker. Therefore, a is equal to pi on 3. And that's the only solution. Now, we don't want to solve for a, we want to solve for x. So we undo the substitution. X on 2 equals pi on 3. Multiply that 2 away. X equals 2 pi on 3. And that is our sole answer. What do you think? There are, I'm sure the book will give different examples around how to do it. The book doesn't use this substitution method, and you don't have to, but I find it nice. All right, last one involves a trick. And this is as hard as it's going to get in stage 1. Root 3 sine 3x equals cos 3x. Alright. Now, we haven't done any when we're mixing these together. However, there are 2 equations you guys know of that combine or link sine and cos. One of them is pi pag. So that's the sine squared plus cos squared equals 1. You can link them there. The other one that links the 2 of them is this, because it links the 2. So, when you see an equation with both sine and cos, it's you can't solve it like that. That's way too hard. Where we go for is we want to jam them together using this. So, I'm going to start off here by dividing both sides by cos 3x. And this is one of those things that when you see how it works, you'll be like, oh yeah, I can do that in the future. So when you have sine and cos combined. Now, I'm just going to do the right-hand side to start with. What is cos 3x divided by cos 3x?
1.
1, because it's the same thing divided by itself. So 1, that's nice. Any guesses what sine 3x divided by cos 3x is?
Root 3 tan x.
Good. It's tan, because sine divided by cos is tan. The root 3 stays. Root 3 tan 3x. We keep the 3x in there, but because, choose colour, this is equal to that. Alright, so from here, root 3 tan 3x equals 1. We want the tan term on its own, so I'm going to divide by root 3. Tan 3x equals 1 on root 3. Cool. Now, having the 3x or something odd in there isn't what we're after, so we choose the replacement. Let a equal 3x, and then think about what are the possible values for a. A is definitely greater than 0. What's the maximum value a can take? 6 pi. Because if x was going between 0 and 2 pi, 3x will go between 0 and 6 pi, because we're multiplying them both by 3. So, you're probably cringing right now, because we're going up to 6 pi, which is 3 laps around the circle. So we're expecting to generate quite a lot of solutions here. Alright, so therefore we have tan A equals 1 on root 3. And now we have. So students, before the SAT, I would be putting in this unit circle to your cheat sheet, and outside of these, writing the tan values, just to save you time calculating them already. I think Martha may have done this. So when does tan equal 1 on root 3? 7 pi on 6, which is?
And pi on 6.
And pi on 6. Okay, there are first two solutions. A equals pi on 6 and 7 pi on 6. And now we do the thing where, okay, we've got what we call our primary solutions, or the first solutions. Now we generate more by going around the circle 2 more times. So go around the circle 2 more times, we're going to add 2 pi, and then add another 2 pi, and generate 2 more pairs of answers, if that makes sense. Probably worth noting that off to the side, 2 pi on 1 is the same as 12 pi on 6. So if we're playing in pi's on 6 for the primary answers, we're going to add on 12 pi on 6 to go around the circle once. So our next solution, instead of being pi on 6, will be pi on 6 plus 12 pi on 6, making it 13 pi on 6. And if you have 7 pi on 6 plus 12 pi on 6, what's the next solution up? 19? Yeah, good. 7 pi and 12 pi is 19 pi on 6. Now, you can either work from here and add 24 pi on 6, or you can work from here and add 12 pi on 6. Because it doesn't matter which one we're going from, we're just in one more loop. So, let's go from here and add another 12 pi on 6. What does that give us? Nice, 25 pi on 6. And then here, we're going another 12 pi on 6, so 19 and 12 is 31. 31 pi on 6. Alright. It's brutal, but as soon as we saw the 0 to 6 pi, we were expecting 6 solutions, and we've got them. Our next step is to replace the A with what we substituted it to be, 3x, and then divide by 3. So I'm going to do that in one step. I'm going to give the x here, and then I'm going to divide all of these by 3. What's pi on 6 divided by 3? Yeah.
Pi on 18.
Nice, pi on 18. Because dividing by 3 is the same basically as timesing the bottom number by that amount. So what's going to happen is it's going to have this entire set of solutions, but now with 18 as the denominator, because we're dividing it by 3. So it's pi on 18, 7 pi on 18, 13 pi on 18. Do you want me to write them? Yes, it's pi on 18, 7 pi on 18, 13 pi on 18. Oh, I didn't write 18. 19 pi on 18, 25 pi on 18, 31 pi on 18. Whew. And that is as difficult as it will get this year. So, trick here to make it into tan, trick with the substitutions, finding the answers, and then replacing the substitution again to get them all. It's a lot, but does it sort of make some sense with the flow? Alright, now, for some reason, the textbook does 5e with simple equations, and you'd think that 5f would be more complex equations. Turns out, it's not. It's 70.3 is the more complex equations. Using calculator, so just plug it in and the calculator will give you decimals, which is really boring. And then these ones are the ones we learned. And I'm also well aware we don't really have time for that right now, so Friday will be a work lesson.
Ugh. What was the calculator?